Hey guys, in this tutorial we're going to take a look at some of the things we could do with curve and box intersections. We're going to be creating something like this, call it the Minecraft aesthetic for obvious reasons. It's very boxy nature. Alright, let's dive into a new document and we'll get rid of this. So I've just made two curves for starters. Just using the interpolate curve, I make something on the base plane, then I turn points on, and I'll just move individual points around until I get something I'm happy with. Alright, I'm going to keep the original curves that I created, and I'm going to select those. Actually, I'll bring in a curve parameter, and then I'm going to reference them. So I'll bring in this one, and then this one. Next I am going to make a bounding box. Oh, let me try that again. Okay, there we go. So now it creates two boxes around these, but I want to create a union box around both curves. And then we're going to get a box properties component if I can aim it right. Okay. So this gives us several useful pieces of information about the box, such as the center, the diagonal vector, which could also give us the size of the box, the area of the box, the volume, and the degeneracy. It's should you ever want to use that. Alright, so the thing we need is the diagonal. That's going to be quite helpful to us. So we're going to use a dvec component. And then using that, that's going to give us an x, y, and z dimension. And so what we're going to try and do is we're going to try and evaluate this box that we've created at each of the at a whole lot of x, y, u. Okay, so because we're evaluating a box, the box parameters are not x, y, and z, but they are u, v, and w, because they exist in this 0 to 1 space. So basically the box is reparameterized. We don't need to reparameterize it, so we just need to plug in a uv and a w value. And those are values between 0 and 1. Okay, so what we want is we want these values to make up how many points we want inside the box, but we don't want these numbers exactly because they are quite large, and if we were to plug them in, they would give us a lot of geometry. So what we're going to do is we're going to add a multiplier for each of them. So multiplier for the x, and then we'll grab a slider as well, and we'll plug that in, and then we'll make copies, and we're going to plug in our y and then our z. And what I am going to do is I'm just going to bring out a panel, so at any point I can, actually before I do that, I will grab an integer component. This integer component is just going to round all my values off really nicely. So then we'll plug these, into here, and this is going to tell me how many divisions I'm going to have in each direction. So I'll bring that down to something a bit more manageable, and then I'm going to grab 3 range components, and our range is 0 to 1. That's fine because our box is automatically reparameterized, and then we're going to plug each of these rounded values into these a number of steps. And then before we plug it into the UVW, we're going to get a cross-reference component, and we're going to cross-reference all 3 of these values so that we get, well, if we were to just plug these 3 in here, we'd get a diagonal line forming the longest list through all of these points. So by cross-referencing them, we're going to get an evaluation point. We're going to get uniform evaluation points across this entire box. Alright, so now we need to create a box at each of these points. And the way we're going to do that is we are going to take, let's see, we are going to take these dimensions, and I will just try this out for starters. We're going to do, we'll see without a panel first. We'll go the x value over the number of boxes we're going to have, and then we're going to create a center box on each of these planes. Turn that off, and we'll see what happens when we plug it in. So at first we can see that the boxes are probably a touch too big. Looks like they are overlapping, and we can just check that. Yeah, you can see they're overlapping a bit. And so what we need to do is we just need to take x over y, and divide that by 2, or we could just do x over 2 times y, and I'll get rid of that parentheses at the front. Alright, so this is our x value, that's our y value, and do we have an error? Plugged in my x and y. X over 2 times y, it's not working. Oh, I accidentally deleted my curve. That was a bit weird. Okay. Alright, there we go, we're back on track. So we'll get rid of this, and when we plug this into our x value, our boxes should all line up, and that looks a lot better. Alright, cool. So that's done. So now we'll just make 2 more copies of this, and we'll do the same thing. So our y and our z are going to go in, and the corresponding y and z values will go in. And so here is our field of boxes. Okay, so now what we could do is we could use a collision test, and that is found in the intersect tab under physical, collision with 1 and many. So the obstacles for collision are going to be our boxes, and our curves are the collision objects, and we're just going to graph those. And so, ooh, hold on, sorry, wrong thing. There. We're going to graph these, and so for each of these we're going to get a true and a false value. So what we can do, let's just grab a list item out, and now we could use a cull pattern, because basically what this is going to do is it's going to give us a list of true or false values, depending on whether the object or the curve intersects the box or not. So when we plug, before we do that, we'll just flatten these lists over here, and so that's going to be our culling pattern. And now we're going to plug the box into the list, and so you can see straight off the bat we get this curve, well, we get this box representation of our curve, which is pretty cool. And if we were to bump this resolution up, this is our resolution slider, you can see we're slowly going to get finer boxes created around this curve. We could also create another culling pattern with this one to get this. Alright, now that's all well and good. But let's try something a bit more interesting. We're going to use a conditional statement. If you've never, I don't think I've done conditional statements, but they're not too complicated. Here's what we're going to do. Instead of using these boxes here, we're going to create a pull point. And so a pull point asks for a point to search from, which will be this, and a geometry to search. And so what this is going to give us for every single item, well, for every single point in this array, it's going to search for the closest point on these curves. And so then it's going to give us a distance value and the point on our curve closest to the point we checked. Okay, and so what we're going to use is we're going to use this distance value, and we're going to use another slider. And I'm going to set that slider to maybe 10, and then I'm going to plug that into my y value, and I'll maybe set it to somewhere around, yeah, 3.962, whatever. Okay, so now we're going to say if x is less than y, true, false. And so what this says is if our distance between the grid and the curve is less than 3.962, then return true. If it's more than 3.962, return false. And so the basic setup for a conditional statement is your if, then your open parentheses. This is your condition that you're testing. Then you do a comma, your true condition, comma, your false condition. Alright. And so now I am going to use this as my cull pattern. Actually, before I do that, let's just see what's going on. I'm gonna graft the curves over here, and I'm gonna turn this off. Okay, so it's doing both of them. I only wanted one of these, so I'm just gonna plug it back into my list item, and oh, okay, hold on. Yes, so we've got an incorrect bit of data structure over here. You can see that it'll form two lists of 960 points. What we actually need is we need 900. Oh, we need how many? We need, what's half of that? It's 480 points, of 480 lists each with 2 points. And so we're going to do a flip matrix to flip that around, and then we'll plug that in, and there we go. Now this isn't going to work just yet, but we'll bump up the resolution to 0.3, and we should see something a little more interesting. So before, what we had was basically, I'll just plug the original result in. So it would give you basically only the neighboring cubes that were right up close to the curve. But with this, what we can do is we can choose how far away from the curve we want to return a box, which is really useful. But what's even more interesting is because we've got this other piece of curve geometry, we could do something a bit more interesting. So maybe I'd want to do an AND conditional statement. What an AND does. Okay, well, what we have are these logic operators that you can see here: the AND, not, or, XOR, and so on and so forth. And so what these do is they'll basically look at your true and false conditions. So if we have, let's just set this up, we'll have true and false. So if we plug true and false in, it's going to return false. If we were to plug true and true in, it will return false. And if we were to plug false and false in, it will return true. So basically, it'll only give us a true value when both of these values are set to true. So what this is going to give us is it's going to give us only the intersection between these two curves. If we wanted to get geometry along the entire curves, we could use the OR gate. And so this will, if this or this is true, then we'll get true. If they're both true, we'll get true, and if they're both false, we'll get false. So we'll plug our OR gate in, and then plug that into the pattern, and that'll give us geometry along both curves. What we could also do is we could use a NOT gate. A NOT gate is a really nice one because it just flips the true or false value. So if I were to plug this in and then plug that into my pattern, it'll give me all the boxes except the ones closest to the curve that you can kind of see going on there. And so what we can actually do is we can compound these. So we could say let's see, we'll go not 1 and 2, and so that'll give us this entire curve except for where this one intersects. Or we could do the opposite, so we could plug this one in here and then that in, and we'd get everything along this curve except where this intersects. So now we could do something a bit more interesting. Let's list item out one of these curves. Oh, let me just grab a list item first. And so that's going to give me, what is it going to give me? I'll turn off my pull points. This list item, okay, I'll turn that off as well. Okay, it's probably giving me that one. You just can't really see it that well. Okay, so that's what we want. Okay, so now we're going to evaluate this curve using some perpendicular frames. And I'll just increase my value of frames. Maybe I want it to go up to 60. Plug that in, and I'll leave it around there somewhere. I'm going to turn my boxes off now because they're a little bit distracting. Okay, so this gives us a plane on each and every single one of these points. It'll give us 32 planes because we're plugging in 31 steps, and so it's going to give us 31 divisions but 32 planes. So now what we can create is, in the previous tutorial we looked at how we could create a curve or a circle using a parametric function. So we're going to do the same thing. I'm going to grab my expression editor, and I'm going to go r times sine of t for our x component, and r times cosine of t. And I just need to change these to r and t. Same thing here, r and t. So now we're going to grab a range, and we are going to plug this into our step number, and so we'll be getting 32 out of here and 32 out of here, so they match up. That's all good. And we're going to set a domain. So I'll start by constructing a domain. We'll keep it between 0 and a multiple of pi. I can plug that in here, and I'll plug a radius value in as well. Maybe I want it to go up to, I don't know, 30. We'll test this out. And I also want a slider for my multiplier of pi, and I probably don't want to go above 20. 20 might even be a bit high. I might only set this to maybe only like 6 or even 5. Okay, so that means this will do 2.5 rotations. So now what we want to do is we want to basically wrap a curve around all of these planes. So it'll wrap right around this curve that we've created. So what we can do is we can use these frames in order to basically as a new coordinate system. And so what we can do is we can go into the vector tab and we can use an oriented point. And so this is basically the same as a construct point component, except it asks for a plane in which to create the number. So we'll plug our plane in, and then we'll plug our x value in and our y value in, and as we increase the slider, you can see we get a nice wraparound curve. That's really cool. And now we can interpolate that curve, or through those points to create a curve, and there we go. So now what we could do, we'll just move this back a touch, and I'm going to create a curve. I'm just going to flatten this and flatten this output in preparation. Plug those in. Okay, and so now what I'm going to do is I'm going to replace all of these into here. I'll just quickly lock this all for a sec because it's going to throw an error as soon as I do this. Actually, maybe I'll just show you guys. It's going to throw an error because I've basically tried to create a loop here, so the geometry would start here and then go around and feed back into itself. And you can't do that in Grasshopper, so it doesn't like that. So what we need to do is we need to plug this curve back into here, and then all will be well. And so now what we should be able to do is okay, well let's just see what happened. Okay, nothing straight off the bat. Maybe we'll increase our y variable to 10, and it's not very clear at the moment. I'll add a second slider for my second value, and then I'll graph that, and I'll bring this one down a bit. Okay, let's see. Okay, so that's quite cool. We can slowly, okay, looks like I'm going to need to increase that slider value. Check it up to 20. So we can basically slowly get rid of everything which is closer to this curve than it is to that curve. This will probably work better if we increase the resolution a bit. We don't want to go too high though, because we might end up crashing the system. So let me just have a think about what else we could do in order to get this working. Oh yeah, what I might do is I'll lower this radius value to somewhere around 6, maybe even 5, and then I'm going to increase my slider. We'll try 0.411, I guess. Okay, now this number's probably a bit too high. Okay, there we go. Kind of getting a result. Actually, no, that is pretty good. If I were to now bake this out, you would see we're getting this nice sort of patterning happen where we're getting geometry projected around this curve, but we're also getting this nice sort of loop around here where we lose a bit of geometry as we follow this rotating curve that sort of forms a helix around itself. And so we could go back here and we could adjust the number of rotations we want. We could adjust the proximity to its reference curve. We could adjust the resolution of these boxes, and we can also adjust the avoid distance. That was for, I'll just leave you guys with a higher resolution version of this so we can see what it looks like. I hope 0.6 works, we'll find out in a sec. Grasshopper's thinking. Still thinking. Yeah, as you can see, it's going to take a while on this one. Okay, there we go. Here's our result. Now let's bake this out. And there we go. Now that is really laggy, but as you can see, that is a very cool result. I am really happy with that. I hope you guys enjoyed that. I think this was a pretty cool tutorial, and we'll see you next time.